Welcome to Mindray Demo Center. Today I am going to show you Mindray vascular solutions. Atherosclerotic plaques can cause stenosis, embolization and thrombosis. However, plaque formation is just the final stage of this disease, while pathological changes that precede it may reveal themselves in functional impairments of the artery wall. How to detect the subtle changes and assess risk factors. The other important issue for vascular studies is hemodynamic and blood flow visualization. Radiologists and sonographers rely on color flow mapping, which is extensively used for blood flow visualization. Color flow has a number of limitations. It is based on assumption of a laminar flow and is angle dependent, and not always suited for detecting of a complex flow which can often be found in pathological, curved or tortuous vessel. Mindray new generation premium ultrasound system Resona 7 provides innovative ultrasound-based technology called V-Flow that can dynamically visualize blood flow while avoiding the inconvenience of angiography. V-Flow breaks the angle-dependent limitation on traditional color Doppler. The V-Flow frame rate is greatly increased up to about 600 frames per second, comparing with 20-24 frames per second in traditional color Doppler. As a result, V-Flow is able to achieve an unprecedented millisecond level temporal resolution, which in turn allows us to detect tiny hemodynamic changes. Measuring velocity magnitude and the direction in any given point lead to much more accurate and precise analysis for vascular studies. Now we will demonstrate V-Flow technology. So, the first thing, we are going to select probe, and we are going to use L9-3 probe. So, first of all, we'll visualize carotid artery and obtain good quality images. Then we'll optimize the image. The next thing, we are going to select V-Flow and we'll start capture. The acquisition time is usually about 1.5 seconds, and after that we can remove transducer away from the patient. On the basis of V-Flow, Mindray Resona 7 offers several amazing quantitative analysis tools: wall shear stress, volume flow, and detailed velocity analysis. Taken together, these parameters can expand diagnostic capabilities in the evaluation of vascular disease. We'll start with a wall shear stress. Wall shear stress is the friction which happens between the blood flow and the vessel wall. This is a key factor for the quantitative assessment of the pathological changes. So the operation is actually very simple. We press wall shear stress button, move the green icon toward the intima, and orient it so the dotted line would be alongside the intima and the solid green line would be perpendicular to the vessel wall. Press the key and we obtain the results. So we get the measurement. Using wall shear stress, it is possible to evaluate the surface of carotid plaques. Big difference in values between various parts of plaque may indicate plaque vulnerability. Another amazing technique is the measurement of the volume flow. In traditional ultrasound platform, volume flow is measured using pulse Doppler, but now V-Flow technology is able to provide much more accurate and precise results. What we need to do is just to define the transverse section of the vessel, and we easily obtain the volume flow. We can measure up to 3 points to compare the volume flow at different positions. Volume flow may be extremely important in case of severe stenosis and occlusion. Another important feature is the detailed assessment of the velocity. We can use the region of interest, put it on specific location within the lumen, and easily measure the maximum velocity, mean velocity, median, and standard deviation velocity within the specific region of interest. In addition to V-flow analysis, radiofrequency-based technologies such as RVQS technology are used to detect changes in the stiffness of the vascular wall and to calculate pulse wave velocity. The pressure waves generated by heart during the systole move walls of the arteries. The propagation velocity of blood pressure waves can be calculated based on stretching of the vascular wall and values of blood pressure. So, to calculate, we will first of all obtain the images of the carotid artery, then press RVQS button and start measurement. And that's it. We obtain data, and based on this data and the blood pressure, we can calculate pulse wave velocity and the hardness coefficient. An increase in this coefficient above 8.3 indicate an increased risk of cardiovascular disease. In addition to RVQAs, radiofrequency-based technologies work RIMT algorithm, which allow to precisely measure the intima media thickness. Unlike the standard automatic measurement of IMT, this technology works in real time and makes a measurement for the 6th cardiac cycle. It's actually very simple. Again, we have to start with the image of the carotid artery, again obtain good quality images, then press on RIMT button, find out the area of interest, and then start calculation. And thanks to radiofrequency technology, measurements became less operator dependent, that greatly improves the accuracy. All exams end with a report. All the information obtained about vascular measurements can be summarized not only in the form of a table, but also in a graphical version using the mapping. Manually marked pathological signs placed on the diagrams of the circulatory system are convenient for data understanding and may be useful in planning further interventions. Taken together, the V-flow technology, RVQS and RIMT provide us a much more detailed picture of different types of flow within the carotid artery compared to conventional color flow mapping. They allow us to measure various quantitative parameters. Using them allow us to assess the physiological state of the vessel wall and risk factors even before the appearance of plaque. They can be used to approach the vulnerable plaque, and they will open new ways for the investigation of the pathologies within the vessels. Thank you very much for your attention.